Alright guys, so we're, based on what we learned yesterday, alright, so yesterday we learned, very important, that 180 degrees equals pi radians. So this is something we're going to memorize and know forevermore. Okay, now, okay, just like yesterday we talked about, you know, when you, when I go like this, and you guys know the angles, right? So, huh? Zoom in?
I cannot see.
Okay, George. Okay? Okay, y'all tell me. Okay, how many degrees is this? 0, 90, 180, 270, 360. But okay, so okay, what if I go this way? Negative 90. Negative 180. Okay, what if I go like this?
360 to revolution.
360 plus 180.
360 plus 180. So you could go more than 360.
540. Right?
540. What if I go like this? Wait, what if I go like this? 360 times 2, which is 720. You get me? Okay, but okay, let me stop the video. Okay, now. But now we're not going to do the degrees, we're going to do it in radians, right? So how many radians is this?
This is
0.
Pi.
Pi. So instead of 180, we're going to say it's pi radians, right? So again, 0.
Pi.
Half pi. I want everybody to do this, okay? Everybody. Okay? No, I mean, like the top. Okay? That means cut out the side conversations, okay? So, how much?
Pi.
Half pi. Or we could say pi over 2, okay? There's 1 half pi. Okay, pi over 2. Pi over 2. Again? Pi.
Pi over 2. 2
pi.
2 pi.
What about this?
1.5
1.5 pi or 1.5 pi, or we can say 3 pi over 2.
3 pi over 2.
Why is it 3 pi over 2?
Because 3 over 2 is 1.5.
1.5 is 1.5, which is 3 halves, right? Think about it. If I do 1 half, 2 halves, and here's the third half. There's 3. It's like, think of it as 3 50-cent coins. You have 3 halves, right? 3 half dollars gives you 150, right? If I have a $half coin and I have 3 halves, 3 half dollars, I get 150, right? So this is 3 pi over 2. Okay, so here,
2 pi.
2 pi. Now it's easier because watch. Now what about this?
4 pi.
4 pi. Okay, what about this? What about this? Watch. 5 pi. What? Watch again.
Yeah.
5 pi. Okay. Now what if I go this way?
Negative
pi over 2. Negative pi. Negative 2 pi. Okay, now what? Okay.
Negative pi to 0. Switching things up.
Okay. Now, okay, hold on. What if I divide this into? Okay, wait. What is this? Pi over
2.
What if I cut that in half?
Pi over 4.
Pi over 4, right? Okay, what if I take my pi and divide it into 3 pieces? So what's this?
Pi over 3.
Pi over 3. What if I cut that 1/3 into half? Pi over
6.
Very good. You got today's lesson. Okay? Alright, so what I need you guys to do is to draw. I mean, yeah, so what you're going to do, pretty much, okay, 2 circles. Okay? You guys can borrow this.
Need it?
No, it's gotta be, take up the whole, make 2 that takes up the whole page.
Oh.
You guys can use my CD as long as you don't scratch my CD, okay?
They're gonna scratch it.
It's not.
Do they have actual music?
That's too big. Isn't the CD too big?
Yeah.
Yeah, the CD's too big.
Like a snail, you know, like
Do they have actual music?
Yeah, some of them. Most of them. Okay, just draw 2 circles. Okay, it doesn't have to be perfect. Just sketch it. Okay, and then mark the center. Okay. Okay. Hurry up, hurry up.
Look like eyes.
Right?
It's 2 circles, right?
Yes. Okay.
like 2 eyes, like bored. It was like 2 bored eyes.
Yeah.
Beautiful.
When you're done with the tape, please pass it on. You know what? Don't make them too big. You're gonna need space. Make them smaller.
Maybe 2 different sizes?
No. Same size, but make them small. So use the inside.
What?
Use the inside.
Now you tell me.
Sorry.
Is this my bad?
Yeah. That's well, a little more space in between would have been better, but it's fine. It's fine. Okay. By the way, I will check your flip book, so make sure your flip books are complete. Okay. All right. Okay. Shh. Okay. Let's start. Okay. So let's start with the left. Okay. How many degrees starts here? 0, right? That's 0 degrees. Yeah? I mean, not degrees, 0 radians. Okay? By the way, shh. Why are we still talking? Okay, this direction is going to be positive, and this direction is going to be negative, right? Just so you know. Okay? All right. If I go the whole circle around, how many radians is that? How many radians is the whole circle? 2, not 2. 2 pi. Okay, so I'm back in the same, no, not and then some, 6 and then some. So it's exactly 2 pi. Okay, so I'm back in the same place, right? Okay, now let's start cutting this circle up by pies. So this activity is called walking around the circle by pies. Okay, we're walking around the circle in pies. Stop. Okay. Oh, I am. Yes. Okay. All right. So if I cut the circle in half, how many radians would be up to the half circle? 1 pi, right? So over here is 1 pi. The whole circle is 2 pi. Yeah? I would like all the side conversations to stop now. I love the engagement, but I don't like I hate the side conversations. Okay, so we could divide it by pi. Can we cut this pi, or not this pi, but this circle into more pieces?
Yes.
Okay, what if we cut the circle into 4th pieces? So go like this. All right, so let's cut each pi in half. So if this was 0 and this is pi, how many degrees is up here?
90.
Not degree, in radians.
0.5.
Pi over 2. This is half a pi.
It depends.
Okay?
If the radius equals 1. Right?
Well, we're assuming this is a unit circle, so the radius equals 1. On a unit circle, the radius always equals 1. Okay? All right. So I want you guys to think about it this way. This is 0 pies. This is half a pi, right?
Yeah.
So this is 1 whole pi, or you could think of it as 2 half pies, right?
True.
Right? Because this is 1 half pi, And this is 2 half pies.
Can't it just be pi?
Which reduces to pi, right?
True.
And then how many half pies are here?
1.5.
3 half pies. Okay? And so when I go back here, how many half pies do I have here? 4 half pies, right? You get that?
Mm-hmm.
I'm sorry, am I not interesting enough for you?
I didn't yell loudly. I just
Okay.
answered while I was.
That's the same thing. Okay. So again, if we're walking around by pies, I have 1 pi and 2 pi. But if I'm walking around by half pies, I have 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Yeah? Okay, now let's divide again. So what if I make an angle that splits each quadrant? By the way, what quadrant is this? 1.
2, 3, 4.
Okay, what quadrant is this?
3, 4, 2, 1.
Good. All right, so let's cut each of these quadrants in half. Okay? All right. So now we're going to walk around the circle in how many pies?
8.
Well, there's each pie we've divided into how many pieces?
8.
4. No, I mean the whole circle is in 4, but then each 1 pie got divided into 4, right? So this is a quarter pie, right? So this is pi over 4. So how many pi over 4s are here? 2 pi over 4, right? Which is reduced to pi over 2, right? Then what's over here? 3 pi over 4, right? So then this is really 4 pi over 4, which reduces to 1 pi. So how many pi over 4 is here? 5 pi over 4. And this is really 6 pi over 4. And so this is 7 pi over 4. And 2 pi is also known as 8 pi over 4. But if you have 8 quarters, you have $2, right? If you have 8 pies, you have 8 quarter pies, you have 2 pies. Get me? You guys feel good about that?
Wait. Yeah.
All right, so write that down. Again, the color coding really helps. So that's why I gave you guys markers and color pencils. Okay? So now, of course, I wouldn't call it 4 pi over 4. I know I could reduce that to just pi. But the reason this is useful is, okay, I was a little bit annoyed because one teacher just gave the entire unit circle to the students just to memorize it. But what's the point of doing that if you don't? That's so much harder. Then you're just like, oh, this is so random. This is 7. This is 5. This is 1. This is 2. Ah! Okay, but look, it's so easy. If you know that this is a 45-degree angle, you know that this is 1/4 of a pi, because the whole pi is right here. But if you know you're like 1 over the whole, well, how many quarters is a whole? It's 4, so then this is 1 more. So it's 5 pi over 4, right? Yeah. If I know that I'm almost at the whole 2 pies, and I know that 2 is 8 over 4, but I'm 1/4 shy, then it's going to be 7 pi over 4, because this is 1/4 shy of being 8 pi over 4. You see that? So when you see this, automatically you can tell that this is 3/4 of a pi. You get me? Okay. So we can divide our pi. When I say pi, I'm talking about this. We divided this pi into how many pieces? 4, right? 1, 2, 3, 4. What's another way we can divide our pi? Into 3 pieces, right? So let's do that over here. Okay? Now, watch me first, because this one you have to be very careful. Watch. Okay, first of all, this is 0, right? And this is 1 pi, right? But in pencil, I'm going to, because this is the tricky part, in pencil, I'm going to go ahead and trace what I already did. We could have used tracing paper, and I thought about it, but I was like, you know what, I don't want to baby you guys. You guys are old enough to do your own, be your own tracing paper. To thine own tracing paper be true. So, okay. So lightly, like in the background, you can do what we did already by doing the the quarter pies, okay? Yeah, make it dotted and light, okay? Not a big deal, like it's not a big deal, okay? So it's the same thing that we already did, pi over 4s, 2 pi over 4, 3 pi over 4, right? Yeah, dotted and light, okay? Dotted and light. Looks like you're wearing a yarmulke. It's actually quite fitting. Okay, so if I'm gonna divide, did you guys do the dotted lines?
Not yet.
Okay. If I'm gonna divide my circle, this is my pie, right? If I'm gonna divide into 3 pieces, is 1/3 gonna be more than 1/4 or less than 1/4?
More.
If you're sharing with 3 people, you get more than if you share with 4 people, right? So 1/3 is gonna be bigger. Okay, so I'm gonna use a different color. I want my 1/3 to be in between 1/4 and 1/2, right? Maybe like this. Okay, and then another 1/3. Okay, maybe that was a little too high. Okay, so this is my 1/3 and 2/3. Get me?
Yeah.
And then I do it again. 1/3 and 2/3. Okay? So think about your x. It shouldn't just be like even, like a square. It should be like a little taller. Your x should be a little taller, not flatter. You see what I'm saying?
Yeah.
It should be more vertical, not more tall than wide.
Horizontal stretch.
Vertical stretch, no?
Oh yeah. Oh, we know.
Yes, we know what I meant, yes. Okay, so what I'm saying is that, look, if your pi over 4 is over here, make sure your pi over 3 is more than pi over 4. It's more than halfway. It's more than halfway, just a little more than halfway, okay? Good, 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 good. Try some colors, Zuni, you'll like it. Good, good, excellent, good. A little more. Look how white this is compared to this. But it's okay. Okay. All right. Try some colors. You'll like it. All right. So, are you mocking me? All right. So this is. Wait. So how can I write this as a fraction? This is 1/3 of a pi, right? So this is a whole pi. This is 1/3 of a pi, meaning it's pi over 3, right?
Yeah.
So this is 2/3, right, of a pi, 2/3 pi. And this is really 3/3 pi. So then this is 4/3 pi, 5/3 pi, and 0 is like 6/3 pi, or 6 pi over 3. Okay? Get me? 6 pi over 3? Because 6 divided by 3 is 2, and that equals, I should have written 2 pi. Ugh, that's ugly. Okay? Shh, I mean, what's your name? Luis. Okay, now. Okay, wait. I'm coming onto something. Something's coming. I don't remember it. Okay. Oh well, I don't remember. Okay, so 1/3, 2. Oh, yes. I want you to be able to notice, because when you see an angle, I need you to be able to easily notice. How are you going to tell the difference between when something is pi over 4 and when something's pi over 3? What's the difference?
A little higher
pi over
than
3 is a little more.
Yeah, pi over 3 is a little bigger than half pi over 4, right?
Yeah, okay.
So, and then anything that has a 3 in the denominator, it's really closer to what? To the y-axis, right? It's closer to the y-axis. If it's 4 pi over 3 and 5 pi over 3, right? Versus pi over 4s and the things that have the 4 on the bottom, Those are like smack in the middle, like a 45-degree angle, right? So which numbers do we have? We have 1, because that's 1 more than 0. We have 3, because it's 1 less than 4. 5, because it's 1 less than 4. We have 7, because it's 1 less than 8. Yeah? Here, 1/3, 2/3. Okay, obviously this is 3 over 3, so this is going to be 4 over 3, 5 over 3. Okay, 6. Okay, good. What if we want to cut it again? So use a different color. I'm going to use yellow this time. If I cut this angle in half. Okay? Yeah, I cut the pi over 3 in half. If I cut a 1/3 in half, what do I get? 1/6. Right? If I was splitting it with 3, if I had money and I split it with 3 people, oh, let's do pizza. If I had a pizza and I have split it with 3 people, each of us gets 1/3 of the pizza. But all of a sudden, I have to cut all those pieces in half. Now how many people can I feed? 6. So it's pi over 6. Okay? Okay. Then where's 2 pi over 6 then? Okay, this is 1/6, so this here is 2/6, right? Which is the same thing as reducing to 1/3, right? And then, where's the next 6th? Cut this one in half, very good. Which is, yeah, because I cut the blue piece in half, right? So this is 3/6. And what does that reduce to? Yeah, which reduces to pi over 2, right? 1/2. Get it? Okay. If I cut this one in half, okay, then over here is going to be, so you see how every other one actually lands on the blue? I actually land on the blue because I'm cutting the blue ones in half. So I have 1/6, 2/6, 3/6, 4/6. Over here is 5/6. Okay? So, and then here I'm landing on here. Okay? So in a sense, the blue and the yellow kind of overlap. You see what I'm saying? So 3 pi over 3 is also 6 pi over 6. Right? And then I cut this one in half, and that's 7 pi over 6. Maybe this is not the best color, huh? It seems to be okay though. That's true. So this one is 9 pi over 6. But you know what? What does 9 pi over 6 reduce to? You know why? I don't memorize it. I just understand how it works, so it's easy to explain. Like, I don't have to memorize how to tie my shoes because I know how it works, so it's easy to explain. You see, you have to understand the why, and then you don't have to memorize anything. Yes. But we could do that on another lesson. Okay, so 11 pi over 6. I could make a video and you can watch it, okay?
I understand.
Okay. Alright. Really? That was awful, but 12 pi over 6 is the same as 6 pi over 3 because it reduces. I don't know if you could read this in any way, shape, or form. Okay? Does this make sense to you? Okay. What do you notice about the ones that have a 6 in the denominator? They're smaller than the thirds. That's right, because they're half. Guess what? The ones that have 6 in the denominator make a wider x. Good, Eric. They make a wider x. They're closer to the x-axis versus the blue one makes a longer x. You see that?
Do you know how those old calculators work? The ones that are like
The abacus, yes, but that's not the subject of this lesson, is it? Isn't it? Okay. So look, you guys notice the ones that have a 6 in the denominator, it's like a wider x. It's an x with a vertical compression, versus the ones with a 3 in the denominator are like a longer x, a taller x with a vertical stretch. Okay? Do you see what I'm saying? The ones that I circled make a longer, taller x. The one with the squares have a wider x. So if you have a 3 on the denominator, is it the tall x or the short x? Tall. If they have a 6 in the denominator, it's a wider x. Okay? Does this make sense to you guys? Okay, so look, if you have a 6 in the denominator, a 3 in the denominator, like 1/3, 2/3, 4/3, 5/3, the x is more tall, skinny and tall. If you have a 6 in the denominator, then the x is more wide. So this versus this, okay? All right, now I want you to turn to your packet. There's a resource page on the end, one of the last pages. Your resource page. This one, I want you to color code it. Okay, you don't have to do it the way I did it.
Based on what we did?
Yes, now you're going to put it all together on one unit circle. Okay? It's the second to last page. Okay? So how might you want to color code this? Let's walk around the pie first in terms of pi, right? Or let's do pi over 2. So this is 0 pi over 2, and then 1 pi over 2, 2 pi over 2, right? So the most reduced fraction is the one we're going to go with, right? So y'all have this?
Yeah. Oh yeah.
So this is 0, this is pi, right? So if I walk around in terms of pi, I get 0 and pi, yeah? If I walk around the circle in terms of half pies, where is your paper, Goose? Get with the program, Goosey. Okay, so if we're walking around the circle in terms of pies, we have 0 and pi. If we're walking in terms of half pies, you have 1 pi over 2, 2 pi over 2, but that one already has a name, and 3 pi over 2. So this time, to minimize confusion, we're going to have only the most reduced form. Okay, if it already has a name that's reduced, we're not going to put the other fraction there, okay? All right, let's take another color and let's do in terms of what? Fourths? Should we walk around in terms of fourths? So that's the dotted line, right? So that's the dotted line. Okay. So this is, we're cutting the circle in terms of what? Pi over 4. So this is 1 pi over 4. This is 2 pi over 4, but it already has a name. What is it? Pi over 2. And then this is 3 pi over 4. Okay. 4 pi over 4, that already has a name. So this is 5 pi over 4. 6 pi over 4 already has a name. And then 7 pi over 4. And then 8 pi over 4 already has a name. So you guys are going to do the rest on your own. Okay, keep going. And do all of them. Okay? You can share your markers. Now basically you guys are going to have to memorize these angles. But don't just memorize it, like
Understand it.
understand it. Thank you. And I forgot to have you guys test each other. If you're having trouble with the fractions, please let me know and I will help you. Please let me know if you're struggling with the fractions because it's important that you understand how it works. I don't know, what should it be? Don't look at mine, just make it, do your own.
Right? Whoa. Oh, that, I got it. Yeah, sorry. Yeah, I thought that was you see who's in there?
I have 1/6.
I have 3.
Half of the 1/3.
Yeah.
Oh no, it's already in
I am on Facebook. Remember
Yes. Yes?
Do you have to copy the rest of it?
Yeah, do the rest. So you guys have to come up with, no, you have to notice the patterns on your own and you have to think of what is the best way to memorize this. Or best way to understand it so that you could easily identify the angles. Because you're going to have to know this pretty much for calculus, pre-calculus. For the rest of the year, we're going to use these all the time. And I'm serious by when I say all the time. Okay. Okay, once you're done, just go ahead and start testing yourself. Cover them up and like put your finger there and then try to figure out which one is which. Okay, notice the patterns. The questions, actually, if you want to test yourself, the questions on page 67 are very good. Number 142, questions 142. Those are very good questions. 142. 142. Okay, then do questions 142. Huh? Oh, we skipped that.
Question what?
142.
Where?
It is?
142. Is it done?
Type 3 is something that will run by the pipe.
Okay, so my first, over the summer, I had my AP Calculus kids just review the unit circle since they should have learned it in pre-calculus and we use it all the time. So this was one of the pages of the first week's test. First week of school, I tested them on this. Usually, the way I test them is I make them make their own circle from scratch. I make them make it and then do exactly like we did, and then just fill it out.
They all pass it.
Oh yeah, this part is the easy part. And this is like stuff you should know from pre-calculus. Good.
I am so confused. Is this gonna be the test? Because you can't.
Yes. Okay, now you guys, let me say it like this. Okay, so watch. So if the pink ones are the 1/3, right? So 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3. If I cut the pink one in half, what do I get?
Radians.
The yellow one, pi over 6. But look, 1 pi over 6, 2 pi over 6 already has a name. 3 pi over 6 already has a name. 4 pi over 6 already has a name. The only one I actually have to name out of 6 is the one over here. Right? So if this is 1 pi over 6, what is this one going to be?
6, 5 pi over 6.
Well, this is, yeah, and how can we know that easily, though? How can we know that? Because the whole thing would have been what? The whole thing would have been 6 pi over 6, right?
Yeah.
But 1 less is 5 pi. And then from 6 pi over 6, 1 more 6 would be
7 pi.
7 pi. And then how much is 2 pi? 2 pi is 12 pi over 6, so 1 less is 11 pi. You see that? I realized that my calculus students didn't know that. They were like, what? We were just memorizing. They just memorized 6, 4, 3, 2, 3, 4, 6. 6, 4, 3, 2, 3, 4, 6. I'm like, what kind of nonsense is that? Okay, does this make sense to you what I said though?
Okay, repeat it one more time.
Okay, let me repeat it one more time. Don't just memorize it like that, okay? If I take the 1/3 in half, this makes sense. I know how to do 1/3 because I took 1 whole pi and I cut it into 3, right? If I cut it into 3, I get the pink lines. If I cut the pink lines in half, I get the yellow line, right? And half of a third is a 6, so I know that's a 6. But all the other ones already have a name, so I don't have to say 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. But, well, because they already have, like, I'm not going to say 2 pi over 6 for this one because it reduces to pi over 3, right?
Does that mean we're not going to have to overwrite it?
So that's why you don't have to say the other one if you just say it in the most reduced form. So you only need to know these two, right? So pi over 6. What's the other side? How am I going to easily know that this is supposed to be 5 pi over 6?
Subtract.
Because I know this is the smallest one, so I know it's going to be the 1/6 one, right?
Yeah.
But I know it's 1/6 less than a whole pi.
True.
So you guys, how many 6 do I have to get a whole pi?
6.
6 over 6. So 1 less is 5 over 6. Well, 1 more 6 is 7 pi over 6. If I want to go to make a 2, how many 6 do I need to make 2? 12 over 6 is 2. Subtract 1 is 11. You see that? No? And the same thing goes with the 4. How many 4s do I need? 1/4. Okay, well, to make a whole, I need 4/4. 1 less is 3/4. 1 more than 4 over 4 is 5 over 4. Right? So the whole thing applies. Okay, so this is beautiful. Okay, now some of you guys are going to try to just do this. Look, 6, 4, 3, 2, 3, 2, 4, 6. 6, 4, 3, 2, 3, 4, 6. If you want to try to memorize it like that, go ahead. Good luck, but I don't think it's the best way. Okay?
Well, our grade was 6, 4, 3.
Okay? All right. What I want you guys to do right now is to test your partners. Okay, so I'm gonna time you guys. Listen, I'm gonna time you guys. I'm gonna give you 1 minute to clean up before the bell, so that gives us 4 minutes. For 2 minutes, one of you guys are gonna cover it and say, okay, tell me which one's this. Tell me which one's this, and you have to test them. And then 2 minutes, you switch. Okay, ready, set, go. 2 minutes.
The red one right here.
Now let's go by 6. Right?
I got this.
How many 6s do you need to make together? Nope. This, you already know this is 180 is 1 5, right?
For the right side is all 5.
6.
1 more minute, and then we're gonna switch. I want to see you guys testing each other.
2, 3, 5.
Cover it.
The reason we don't write it is simple.
Serious.
I want to see you guys testing each other. Come on. Hey, this is not free time. Come on, test each other. Do it again. Randomly. Okay, pick my
What goes to make
Good job, Antonio. Good job, those are for me. Good job, guys.
8 5 6.
Too late.
I was gonna say that.
90 degrees.
You gotta go like this. How much is this one?
How do you get 2 point? We have 4. How do you get 2 power 4?
That's what I said, man.
Oh!
That's how you test each other. All right, switch. Now the other person. 2 minutes. Switch.
How do you get 2 pi and you use the same 4 when I told you?
He's like 5:30.
You're getting the gist of it.
Let's see you guys test each other. Come on. Like this. Which one is this one? Don't test each other. Come on. 1 more minute. This will be on your test.
Let's do it Wednesday. Are we doing it Wednesday?
What's 160 degrees?
The test is going to be still on Wednesday, even though it's special schedule, because this class is still 55 minutes long.
The brown ones and this one. When you're doing 6, the brown ones. Just skip.
All right, you guys. Give me your attention. We have 1 minute before dismissal. Listen, I need you guys to put the markers back and keep whatever circular tape things you had, just keep them neatly there. Put that on top of person C's desk, on top of person C's little star, or whatever, person C. Do you guys remember what your homework is?
Everything.
Do your homework.
And?
Everything.
Catch up on study.
And?
Watch videos.
What do you mean by study?
Study.
Organize yourself. Get an idea of what you know and what you don't know. Okay? Get ready for the test. I'll start tomorrow. I'm not going to wait till the day of the test.
From which to which are you gonna check?
Anything.
Because you know how I lost it, I have to redo it.
Really? I'm sure you can find it. Well, look in your grade book, in your Illuminate, because the ones I've already checked, you already have credit for it. Why are you guys walking around? See you tomorrow.